Hi guys, so today we're going to do lesson 8-5 and it's all about envelope heights and it's found on page 286 and 287. And you'll notice that I already made my line plot for the data that we're going to put in here. And so the range of it, and the range means from the smallest to the largest, so the range is going to be between 3 and 6. So in the problem it says the Right Stuff, a stationery store, sells a variety of different size envelopes for business and personal correspondence. The heights and lengths of the envelopes are given in the tables below. All measurements are in inches. So underneath here I'm going to label it inches. Okay. And then it says plot the heights of all the business and personal envelopes on the line plot below. So I'm going to title it up here Heights of Envelopes. Okay. So that means I'm going to have to take all the data from the table for the height here, for the business, and the height for the personal. And before I even start, I just want to look at my line. And I'm going to notice that the interval here from 3 to 4, what is it broken up into? So I can say there's 1, 2, 3, 4, 5, 6, 7, 8 pieces in one whole jump. So I know these marks are in eighths. So I just might label those 1/8, 2/8, 3/8. I know a half is 4/8, 5/8, 6/8, 7/8, and then there's my 8/8. And I'm going to do it again. And it might be hard to read because I'm having to write so small. Sorry. 5/8, 6/8, 7/8. And that will just really help me when I'm going to plot my data that I don't accidentally put it in the wrong spot. Okay, so the first one I have is 3 1/2 and 3 5/8, 3 5/8, 3 3/4. And so you have to think to yourself 3/4, and I have to make 3/4 into eighths. So what did I do to that 4 to make it an 8? I times it by 2. So I can times it by 2 over 2, and 3 times 2 is 6. So 3/4 is 6/8. So underneath there I'm just going to write a 3/4 also. 3 7/8, 3 7/8, 4, 4 1/8, 4 1/2, 4 3/4, and I already know 3/4 is 6/8, and 5. And then the last one here is all the way at 6. So those are all the business envelopes. Then I have to do the personal envelopes, and I'm just going straight down so I know I don't make any mistakes. So then I have a 3 5/8 again, and a 4 3/8, and a 4 3/4, which is that 6/8 again, and a 5 1/4. And 1/4, when I do a 1/4 conversion, 1/4, if I need to put it into eighths, for the 4 I did 4 times 2, so I'd have to do 1 times 2, which is 2, so that would be 2/8. So 5 1/4 is 5 2/8. 5 1/2, 5 3/4, which is that 6/8 again, and a 6. Okay, so I have all my data put on to my line plot. And if I look at it, the range of the envelope sizes is that the range means the smallest to the largest. So the smallest envelope size I have is 3 1/2, and the largest is a 6. Okay, so I've just done page 286 right here. I titled it Heights of Envelopes. I put the measurement, what it's measured in, and then I put all of my data on my line plot. So now I can go to page 287 and answer my questions. So it says use the completed line plot on page 286 to answer the questions. Show your work in the space provided. What is the largest envelope height sold? So it's not asking you which one sold the most. it wants to know what is the largest one, and that means we're talking about the inches. So which one is the absolute largest sold? And that one is the 6. Okay? And then if we talk about what is the smallest one, even though our line plot goes down to 3, do we have any that have been sold at 3? We don't. The smallest one was over here at 3.5. Which envelope height is stocked the most by the right stuff? Okay, so we can look here, and now we're talking about the most. And that math term is the mode. So something that is the mode is the most. And that one is here, because that one has the 3 x's, and that one is 3 5/8, right? Which envelope height is stocked by them? Okay, number 4. What is the difference between the largest and the smallest heights? So we need to find the difference, and we know that's subtraction. So the largest is 6, and the smallest is 3.5. And when I do my subtraction, I know I need to get some halves. So I'm going to borrow from my 6, and it's going to become a 5 and 2 over 2, 2 halves, because we know that's 1 whole. And 5 and 1 whole is 6. So 2 halves minus 1 half is 1 half. 5 minus 3 is 2. So we have 2.5. Number 5. In the United States, the most popular business envelope is 4 1/8 inch by 9 1/2 inches. It is called the standard 10 and number 10 envelope. How many of the envelopes sold at the right stuff have a height larger than 4 1/8 inch? So I'm going to go to that 4 1/8 right here, and it's asking how many envelopes that they stock are larger than that. So we can't count the 4 1/8 because 4 1/8 is 4 1/8. It's not larger. So we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many of the envelopes sold have a height smaller than 4 1/8? So again, we'll go to that 4 1/8. And we won't count it because it needs to be smaller. 1, 2, 3, 4, 5, 6, 7, 8. How much larger is the height of the number 10 envelope than the smallest one sold? So what is the height of the number 10 envelope? Okay, we know that the height, by looking at the number 5 story, it says 4 1/8. And it says how much larger is the height of the number 10 than the smallest one sold. So 4 1/8, how much bigger is 4 1/8 compared to 3 1/2? And when we look at this, we can't subtract problems with different denominators in the fractions. So we need to turn that 1/2 into eighths, okay? And how many eighths is half? Okay? So we know to get to eighths, you could do 2 times 4 is 8, so 1 times 4 is 4. Okay? So 1/2 is the same as 4/8. So I'm going to go ahead and I'm going to turn that 1/2 into 4/8. Okay, so now it's 3 4/8. And I could have looked at that too because I know 1/8, 2/8, 3/8, 4/8. Okay? So I can't do 1/8 minus 4/8, so I have to take some away from that 4. So that's going to be 3, and I'm going to give this 1/8 8/8 more. So now up here, I don't have 8/8 anymore. I have 9/8. So 9/8 minus 4/8 is 5/8. 3 minus 3 is 0. So how much? What's the difference? It's 5/8. And then how much smaller is the height of the number 10 envelope than the largest one sold? So the largest one is 6. And the number 10, again, is 4 1/8. And we need to find out how much smaller. I can't do no eighths minus 1/8, and it doesn't just fall down. I have to have some eighths. So I'm going to take that 6, and it's going to become a 5 8/8. 8/8 minus 1/8 is 7/8. 5 minus 4 is 1. So the difference there is 1 and 7/8. And that's it. So not too tough today. You just want to make sure that you practice getting the same denominators, common denominators for subtracting fractions. Okay, good luck guys.